Okay, so we're looking at the Math 1101 Unit 2 practice problem set. And let's go to the first question. It says, given the following table indicate the one correct response. And so we're looking at whether this is a function of x, if it's linear, exponential, or neither. Okay. Now I can look at this data and say that it's certainly a function because we don't have any repeated x values. So every x value has a unique output. I've entered the data into my calculator already off screen, so you can see it here. And what I'm going to check first is I'm going to look at the average rates of change, and I'm going to do that using delta list. So delta list L2 divided by delta list L1 and we can see from the data that the average rate of change is not constant. So that tells us that it's not linear. We can also see that all the average rates of change are positive and increasing. So this does seem to be an exponential function, but let's make sure. So there's a couple of things we could do. We could look to see that the ratios of the L2 values are constant. That's one thing that we look for with an exponential function. Another thing that we could do is we could just do exponential regression. That's what I'm going to do here. I'm going to do exponential regression I think I messed up. Hold on. Okay, so as I was saying, I'm doing exponential regression here. I had to put in a parenthesis or a comma. And what I'm looking to see is I'm going to actually look at the correlation coefficient. So I'm going to go to vars, statistics, equation, and go to number 7. And look at my correlation coefficient. So while yes, that's not exactly 1, this would round to 1 within, what is that? 1, 2, 3, 7 or 8 digits worth. So this is an exponential function. This is close enough to perfectly correlated. Okay. All right. So C is our answer, and we actually found the function right here. Those are the a and b values for a times b to the x. All right, let's move on to number 2. I'm going to enter this data off screen as well. Okay, so I've entered my data for question number 2, 0, 1, 2, 3, 4, and then here's the associated y values. And just like number 1, I'm going to first look at the average rates of change. So I'm going to do the average rate of change command. And in this case, I see the same average rate of change for each interval. And that tells me that we actually have a linear function. I didn't even address the fact that this is a function, but it certainly is a function for the same reason that this one was a function, and that is that each x value has a unique y value. And in fact, we've established more than that it is linear. Okay, so let's move along. Question number 3. An investor deposits $3,000 into an account paying 2.75% interest compounded annually. That means compounded one time per year. Find a model A of t that gives the account balance in dollars as a function of the number of years after the initial deposit. And then we have a whole bunch of questions about our model. So when you see a financial model, your first instinct is probably to use the compound interest equation, and we could use that here. Just to remind you of what that equation is, I'll write it right here. That's a of t equals a sub 0 times 1 plus APR over n to the nt. That's the compound interest equation. So you could certainly use that here. The only thing is that in this case, since we're compounding annually, n is 1. So you could use this model with just n being 1, or you could just use the standard exponential growth rate model. Either one will give you the correct answer. So since I've already got this written here, I'll use it. So my model is going to be $3,000. That's my initial value. And then 1, my APR is 0.0275. And yes, this is over a 1. Doesn't really make a difference since it's a 1, but it is there. And then that's 1 times t. Okay. Alright, so I know I'm going to need to enter this in the calculator and do a bunch of stuff with it, so let's do so now. So 3,000, 1 plus 0.0275. And I'm not going to bother with the fraction of 1 right here, since I know that doesn't actually mathematically change anything, nor am I going to put the 1 in the variable, in the exponent in this case, since again it won't change anything. But there's my model. Question B says, find the amount in the account after 4 years. So to do that, we're going to, we're going to go to vars, yvars function, y1, and we just want to evaluate the model after 4 years have elapsed. So that's just y1 of 4. So there's your answer, $3,343.86. Okay. How long will it take after the initial deposit for the account balance to reach 4,000? So this is a calc intersect question, because I'm looking for an input of the function, and I know the output, and I just messed that up. Let me fix that. Here we go. So I want to intersect these two functions. I'm going to go to the table and see how long it's going to take me to do that. Now my table happened to already start at 43 for some reason. I was doing something, and that's why it's there, but I'm going to restart my table at 0. And now we can get a good measure. Okay, so there you go. You see from between year 10 and 11, somewhere in there is where we cross this $4,000 mark. So that gives me an X max for my window. I'm going to put in 15, and then I'm going to do zoom fit with that. I just use 15 because that's a number that's larger than the intersection, so it should give me enough space in the left and right to see the picture properly, I hope. Alright, so there we go. Now let's do calc intersect. And we see our intersection point is 10.604. Alright, I just rounded to 2 decimal places here. Find the account's doubling time. So the doubling time, as you should know, is the amount of time it takes for the initial amount, or any amount, to double. In this case, the initial amount is $3,000. And so this actually, again, is a calc intersect question, but now I'm going to be intersecting with $6,000. And I probably need to make my window larger. I could check the table, but I'm just going to go ahead and make it 25. That should be plenty. And then we'll do zoom fit again. And basically just repeat what we did in the last part of this problem. And you see I have an issue here because my intersection is off screen, so I guess I shouldn't have been so quick to set my intersection. Alright, let me fix that. So I'm going to make my window, I'm going to make it be 40. Do zoom fit again, and hopefully this time things will come out nicer. All right. So we see our doubling time is 25.55. And that's years. Finally, we're asked to find the monthly growth rate for the account to 3 decimal places. So notice that this is an annual rate that we are given. We want to put this in monthly terms, so we are changing the unit. And the procedure for that is always that we go to the factor. So we need to first write down the factor. Now I know I've done this already in the model, but there's the annual factor. To turn this into a monthly factor, we need to raise this to the 1/12th power. Then all of that will be the monthly factor. And then once I get this value, I'm going to subtract 1 from this. And then finally, to put it in percent form, I will multiply the whole thing by 100. And then that will give me my percent. So let's just go to the calculator and do all that now. So we need to be careful with our parentheses, but this is 1.0275 raised to the, and notice I put a parentheses around my fraction. That's because I want to make sure that it's understood correctly by the calculator. Alright, there's my monthly factor. I'm going to take 1 away from that and then multiply it by 100. And that is my monthly growth rate. So my monthly growth rate is 0.226%. Okay. So it's a small number, 0.226%. All right. Okay, so that takes care of question number 3. I'm going to stop this video at this question, and we will start the next video at question number 4.